Greetings, my friend! Welcome back to Space Enjoyer. We live on a wonderful planet with comfortable conditions for the origin and development of life. This planet orbits a small yellow dwarf star called the Sun. But did you know that there are planets that are not gravitationally bound to any star, brown dwarf or other planet, although they may have satellites? They are called rogue planets. It is about such planets that we will talk about in this video. Rogue planets originate from planetary systems in which they are formed and later ejected. They can also form on their own outside a planetary system. The Milky Way alone may have billions to trillions of rogue planets. A range the upcoming Nancy Grace Roman Space Telescope, which is a NASA infrared space telescope currently in development, will likely be able to narrow down. Some planetary mass objects may have formed in a similar way to stars, and the International Astronomical Union has proposed that such objects can be called sub-brown dwarfs. A possible example is CHA 110013 7734 444, which may have been ejected and become a rogue planet, or formed on its own to become a sub-brown dwarf. Astronomers have used the Herschel Space Observatory and the Very Large Telescope to observe a very young free-floating planetary mass object, OTS-44, and demonstrate that the processes characterizing the canonical star-like mode of formation apply to isolated objects down to a few Jupiter masses. Herschel far-infrared observations have shown that OTS-44 is surrounded by a disk of at least 10 Earth masses, and thus could eventually form a mini-planetary system. At this stage, in order to continue the story, we need to understand what is gravitational microlensing. Gravitational microlensing is an astronomical phenomenon due to the gravitational lens effect. It can be used to detect objects that range from the mass of a planet to the mass of a star, regardless of the light they emit. A gravitational lens is a distribution of matter, such as a cluster of galaxies, between a distant light source and an observer that is capable of bending the light from the source as the light travels toward the observer. The gravitational lensing effect is predicted by the Albert Einstein's general theory of relativity. Astrophysicist Takahiro Sumi of Osaka University in Japan and his colleagues, who formed the microlensing observations in astrophysics and the optical gravitational lensing experiment collaborations, published their study of microlensing in 2011. They observed 50 million stars in the Milky Way and found 474 incidents of microlensing, 10 of which were brief enough to be planets of around Jupiter's size with no associated star in the immediate vicinity. The researchers estimated from their observations that there are nearly 2 Jupiter-mass rogue planets for every star in the Milky Way. One study suggested a much larger number, up to 100,000 times more rogue planets than stars in the Milky Way, though this study encompassed hypothetical objects much smaller than Jupiter. A 2017 study by the scientists of Warsaw University Observatory indicated an upper limit of Jupiter mass free-floating or wide-orbit planets of 0.25 planets per main sequence star in the Milky Way. Nearby rogue planet candidates include WISE 0855 0714 at a distance of 7.27 light-years. In September 2020, astronomers using microlensing techniques for the first time reported the detection of an Earth-mass rogue planet named OGLE 2016 BLG 1928, unbounded to any star and free-floating in the Milky Way galaxy. In December 2021, the largest ever group of rogue planets was discovered, numbering at least 70 and up to 170 depending on the assumed age. I tried to make a small simulation using Python which would to some extent demonstrate how our Earth could become a rogue planet if an object comparable to the Sun in terms of mass and gravity flew somewhere relatively close. Here you can see the result of such a simulation. Interstellar planets generate little heat and are not heated by a star. However, in 1998, David J. Stevenson theorized that some planet-sized objects adrift in interstellar space might sustain a thick atmosphere that would not freeze out. He proposed that these atmospheres would be preserved by the pressure-induced far-infrared radiation opacity of a thick hydrogen-containing atmosphere. During planetary system formation, several small protoplanetary bodies may be ejected from the system. An ejected body would receive less of the stellar-generated ultraviolet light that can strip away the lighter elements of its atmosphere. Even an Earth-sized body would have enough gravity to prevent the escape of the hydrogen and helium in its atmosphere. In an Earth-sized object, the geothermal energy from residual core radioisotope decay could maintain a surface temperature above the melting point of water, allowing liquid water oceans to exist. These planets are likely to remain geologically active for long periods. If they have geodynamic created projective magnetosphere and seafloor volcanism, hydrothermal vents could provide energy for life. These bodies would be difficult to detect because of their weak thermal microwave radiation emissions, although reflected solar radiation and far-infrared thermal emissions may be detectable from an object that is less than 1000 astronomical units from Earth. Around 5% of Earth-sized ejected planets with Moon-sized natural satellites would retain their satellites after ejection. A large satellite would be a source of significant geological tidal heating. The thought that somewhere out there, on planets wandering alone in interstellar space, there may be life makes me tremble. And what do you think such a life could be like? Please share your opinion in the comments. Thank you for your attention. If you like this video, please leave a like, subscribe to the channel and check out my other videos. And I'll see you soon.